Welcome to myprojectbazaar.com. Now I am going to discuss about title for this project. Our project title is ESRQ, an efficient secure routing method in wireless sensor network based on Q-learning. So our project modified title is, that is the enhancement title is, a secure hash key based routing with PS efficient data aggregation in wireless sensor networks. This is the enhancement work for the base paper work. Now I am going to explain about abstract for this project. Our project abstract is the need for efficient optimization of the network resources to cover this lifetime of large scale and dense deployment of the wireless sensor network. Upon the door for the researchers to study and producing the efficient cluster techniques. The sensor node can collaborate to preserving, collecting and processing the data from the network and transmitting the information the observer. The sensor nodes are very limited by energy and the battery cannot be replaced, and the nodes abilities of computing, communication and the memory are all limited. The clustering has proven an efficient approaches for organizing a large scale SDWSN into connected group, increasing the lifetime and the reliability of the search network. Distance of the nodes from the base station and the internode distance can have a high influences on saving the energy and extension the network lifetime. In this process, a PSO based data transmission in SDWSN is proposed. PSO algorithm to optimizing the clustering process by considering the energy, velocity, speed of the each node. This feature will have a great efficient prolonging the network lifetime as it's replacing the nodes. Now I am going to explain about the flow diagram for this project. Our project flow is represented in the flow format. Wireless networks are comparing of a numerical of the sensor nodes and the dot deployed in the field. The radio channels we using the 2-ray ground, we deploying the 100 nodes of the 100 numbers of the nodes, and the transmission range is 1000 meter. So x-axis is 1000 meter and y-axis is 1000 meter. We considering a file transfer protocol FTP and the random chosen different source and the destination connections. Our network containing the source, cluster volunteer and destination node, every source node in the byte format. 1000 nodes are randomly deployed in that region. After the normal nodes are deployed, the base station node is fixed and all other nodes are in the random mobility model. Random mobility model means we are not given the destination locations. All the nodes have the same energy while node deployment. The cluster head is selected depends upon the residual energy of the node. The node which have higher energy is taken as the cluster head and all the transmission between the nodes are done via the layer head. We will be implemented PSO in WSN using the fitness function calculation, which including the 3 parameter position, velocity, speed of the each node and energy based on the TX power, or TX means transmit power, receiving power, idle power and the sensing power. This will finding the optimal routing. In our PSO, we will maintain the routing table which provides better network lifetime. The data transmission is done by using the TCP connection protocol. The node is selected based upon the energy and the position of the node. If the node is nearest to the destination, then the data delivery sends the data destination, else it sends the data via the neighbor. After the data transmission, we finding the performance evaluation. Performance measures like throughput, packet delivery ratio, delay, energy consumption are calculated. Throughput is nothing but throughput is the rate of the producing or the rate which something can be processed. Packet delivery ratio, main protocol in the wireless sensor network, using the packet delivery ratio as a matrix to selecting the best route transmission of the rate or power. We comparing our system delay with existing system. The superior work have higher delay than our system. The total energy is calculated by using the total energy divided by a number of nodes. Now I am going to discuss about output for this project. This is our output window. Now I am going to run our project. First open the root form and open the terminal window. Our project coding is code folder. So go to the code folder and select main.m file, main.tcl file. So I am going to run this file. Now I am going to change the directory root into code folder. Now the directory is changed root into code. Next one is ns space main.tcl. This command is used to run our main.tcl file. So the coding is running. In this process we implemented in randomly 100 nodes are deployed and the position of the each node is find and the clustering is done and cluster head is selected. After the cluster head selection, the PSO implementation is done here. The PSO algorithm is used to finding the node velocity and the speed and energy of the each node. This is our NAM window. So NAM console means network animator window. This is our out.NAM window. This is a graphical representation for the output window. This is zoom in button, play forward button, fast forward button and backward button, rewind button. Now I am going to run the project. This is speed setup for running. So all the nodes are created and the clusters is formed and cluster head is selected dynamically based on the residual energy. So the data transmission is done here. Here all the information are displayed in the below display button. So after the data transmission we finding the performance measures for this project. So here go to the readme file and right click the file, open with gedit option to see the running procedure for this process. So first one is an open the terminal window and following these two commands are used to run the main file and for running graph procedures. So first one is an energy graph. Command is awk -f energy dot awk out.tr. This command is used to generate our energy dot xg graph. After the graph creation we run the xgraph space energy dot xg command is used to display our energy values for the output. So this is energy for this overall network. Next one is delay graph. So awk -f delay dot awk out.tr. This command is used to generating our delay of the network. This command is used to display our delay for this project. Next one is pdr awk -f pdr.awk out.tr. This command is used to generate our packet delivery ratio for the graph. After that graph generation we run the pdr.xg. So this is packet delivery ratio between the source and the destination and overall network. Finally we are calculating the throughput graph. Throughput graph is displayed here. So this is throughput graph. The running procedure is done. Thank you for listening. Our demo is completed. Thank you.